Processes related to growth and aging in plants involve the effect of hormones. Hormones. Hormone. Hormone. Hormones. Today I'll talk about the two aging processes. The the ripening of fruit and the falling of leaves in autumn. These processes involve a hormone called estrogen. What is estrogen? It's a chemical, a gas produced by plants as a hormone. Estrogen is unique among plant hormones because it's the only hormone that's a gas. The gaseous state is important. Gaseous, gaseous. Gaseous state is important because it enables estrogen to move through the plant. Like all other hormones, estrogen triggers a certain response in the plant. Estrogen is associated with a variety of aging processes. One example of the aging process is the ripening of fruit. The ripening of fruit involves several changes in structure and metabolism. And some of these changes are aging processes. One change is weakening of cell walls, which softens the fruit. Another is a decrease in chlorophyll content, which causes the fruit to lose its greenness. Estrogen initiate or hasten both of these changes and also causes some ripened fruit to drop from the plant. Hasten. 猫ちゃんが好きです。hasten. Both of these changes and also causes a chain reaction occurs. お母さんみたいなこと言うな。occurs.違う。occurs during ripening. The aging cells then release more estrogen. Because estrogen is a gas, the signal to ripen spread from fruit to fruit. You've heard the expression, one bad apple spoils the whole lot. Well, it really is true. Yes, Randy? So, when we buy fruit like peaches that are still kind of green and we store them in a plastic bag, and the peaches ripen faster, is this because of estrogen? I mean, I think I get it. The bag traps the estrogen gas and speeds up the ripening. Right. That's exactly what happens. Ethylene accumulates inside the plastic bag, and this starts a chain reaction. The signal to ripen spreads from one peach to another, and this causes all of the peaches to ripen faster. By the way, the role of ethylene was discovered in sort of an Interesting way. A century ago, citrus growers used to ripen fruit by curing it in sheds that were heated by kerosene stoves. The growers thought it was the heat from the stoves that ripened the fruit. However, they later discovered that the fruit didn't ripen after they started using newer, cleaner burning stoves. Botanists figured out that the reason the fruit ripened in the sheds with kerosene stove was because of ethylene, not heat. Because, as it turns out, ethylene is a byproduct of kerosene combustion. Nowadays, a lot of fruit is ripened in huge storage containers that have ethylene gas piped in. It's a new variation on the old curing shed. But in other case, storage facility have to slow down the ripening caused by natural ethylene. For example, apples are stored in bins that are flushed with carbon dioxide. Bins. That are flushed with carbon dioxide. Circulating the air with carbon dioxide prevents ethylene from accumulating, and carbon dioxide slows down the action of whatever ethylene isn't flushed away. This is how apples can be stored for several months before they are shipped to supermarkets. Another aging process in plants where ethylene plays a role is the falling of leaves in autumn. When a leaf falls from a tree, the breaking point is a layer near the base of the leaf's stalk. A change in the balance of two hormones, ethylene and auxin, controls the falling of leaves. An aging leaf produces less and less auxin, a hormone that stimulates cell growth. The drop in action makes the cell of the breaking layer more sensitive to ethylene. As the influence of ethylene becomes stronger, the cells start producing enzymes that weaken the cell's wall of the breaking enzymes that weaken the cell wall of the breaking layer. Finally, with the help of wind and rain, the leaf breaks away at that layer and falls for the tree.